Day 450 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2210, count hills and valleys in an array. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index integer array nums and index I is part of a hill in nums if the closest non-equal neighbors of I are smaller than nums of I. Similarly, an index I is part of a valley in nums if the closest non-equal neighbors of I are larger than nums of I. Adjacent indices I and j are part of the same hill if or valley if nums of I is equal to nums of j. Note that for an index to be part of a hill or valley, it must have a non-equal neighbor on both the left and the right of the index. Return the number of hills and valleys in nums. All right, y'all, so let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have our input nums equals an array of integers 2, 4, 1, 1, 6, and 5. Our output is 3. An explanation says at index 0, there is no non-equal neighbor of 2 on the left, so index 0 is neither a hill nor a valley. So that's important too, because it says right here, it must have non-equal neighbor on both the left and the right of the index. So since zero index does not have any neighbors on the left, it's neither a hill nor a valley. So let's look at index 1. At index 1, the closest non-equal neighbors of 4 are 2 and 1. Since 4 is greater than 2 and 4 is greater than 1, index 1 is a hill. So as you can see, index 1 is right here. When we come to the left of index 1, it's smaller than 4. When we come to the right of index 1, it's smaller than 4. That means this index or this 4 is a hill because its two neighbors are valleys, right? It's hills and valleys. So just imagine the hill going up to 4 and then coming back down to 1. So now let's go take a look at index 2. At index 2, the closest non-equal neighbors of 1 are 4 and 6. Since 1 is less than 4 and 1 is less than 6, index 2 is a valley. So right now we're at index 2. Come to the left of index 2, we see a 4, 4 is greater than 1. Then we come to the right of index 2, we see it's another 1, right? So these two equal each other, and it says right here, adjacent indices I and j that are part of are part of the same hill or valley if nums I and nums j are equal. So in this case, they're part of the same valley because when we come to the left, when we go to the right of this one, imagine these are the same valleys, or these two indexes are the same valley, then we go to the right because once again it says the closest non-equal neighbor. So the closest non-equal neighbor to index 2 would be this 6 right here, which is greater than 1. So that makes these two ones a valley. So similarly in index 3, so this is index 3, is the same thing, just on the other side. The closest non-equal neighbors of 1 are 4 and 6. Since 1 is less than 4 and 1 is less than 6, index 3 is a valley. But note that it is part of the same valley as index 2, like we talked about earlier. So these are the same valley because they're equal. And when we come to the left, 4 is greater than 1, and when we come to the right, 6 is greater than 1, so that makes this a valley. So right now we have one hill right here, and we have one valley right here. Boom. Then we're at index 4. Index 4, the closest non-equal neighbors of 6 are 1 and 5. Since 6 is greater than 1 and 6 is greater than 5, index 4 is a hill. So boom, this is our third hill right here. Boom, so we have a hill right here. Then we have a valley right here. Then we have a hill right here. Boom. Then we have finally at index 5, there is no non-equal neighbor of 5 on the right. So index 5 is neither a hill nor a valley. There are 3 hills and valleys, so we return 3. So just like at index 0, there is no hill, or there's no neighbor on the right side, right? So once again, we need neighbors on both the left and the right side. So since this has no neighbor on the right side, it's neither a hill nor a valley. So these are 3 hills and valleys. We have a hill right here, a valley right here, and a hill right here. That's 3 hills and valleys in total. So our output is 3. So let's go ahead and look at example 2 where it gets a little tricky. They try to throw just more equal numbers, I guess you could say. And here right here we have on the left neighbor is greater, but on the right neighbor is less than. So let's go ahead and look at that and see how they handle that. So in example 2, we have the input nums equals an array of integers 6, 6, 5, 5, 4, and 1. This time the output is 0. Let's take a look at the explanation because there are no hills and valleys. So at index 0, there's no non-equal neighbor of 6 on the left, so index 0 is neither a hill nor a valley. So this 6 we already know is neither a hill nor a valley because it's at index 0. Then we come to index 1. There's no non-equal neighbor of 6 on the left, so index 1 is neither a hill nor a valley. So when we come to this index right here, index 1, this is a 6. There is no non-equal neighbor of the 6, right? Because we come to the left, it's equal. Then we go to the left of that, there's nothing there. So once again, there is no non-equal neighbor of 6 on the left. So index 1, once again, this is neither a hill nor a valley. So now let's look at index 2. So index 2, the closest non-equal neighbors of 5 are 6 and 4. Since 5 is less than 6 and 5 is greater than 4, index is neither a hill nor a valley. So right here, we have index 2, we have a 6 on the left, but then we come right here and we have a 4, right? Because once again, the closest non-equal neighbor. So the closest non-equal neighbor, this would be the closest neighbor, but it's equal. So the closest non-equal neighbor would be a 4, but 5 is greater than 4, but it's less than 6. So it's, once again, it's neither, index 2 is neither a hill nor a valley. So let's look at index 3, which is right here, this 5 right here. At index 3, the closest non-equal neighbors of 5 are 6 and 4 again. Same thing, since 5 is less than 6 and 5 is greater than 4, index 3 is neither a hill nor a valley. So now let's look at index 4. Boom, but it's the same principles as before. At index 4, the closest non-equal neighbors of 4 are 5 and 1. Since 4 is less than 5, but 4 is greater than 1, index 4 is neither a hill nor a valley, once again, because it's like, just imagine the hill. If it was a hill, it would be going down. We don't see the other side of the hill, so we don't know what it is. It's neither a hill nor a valley. So finally, at index 5, there's no non-equal neighbor of 1 on the right, so index 5 is neither a hill nor a valley. So right here, index 5, same thing. There's no non-equal neighbor on the right, so it's neither a hill nor a valley. So in the end, there are 0 hills and valleys, so we return our output, which is 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get into it. First thing we're going to do, we're just going to declare a variable. We're going to call it new R. And we're just going to set that equal to an array of integers and put the parentheses like that. Then we're going to remove the consecutive duplicates from the input array. So we're going to say for num and nums, we're going to open up the bracket. And we're going to say if new R dot is empty, then what we're going to do is we're going to say new R dot append, open up the parentheses num. Then we're going to come right here. We're going to say else if new R square bracket new R dot count minus 1 does not equal num. Then we're going to open up the bracket and we're going to say new R dot append, open up the parentheses and pass in num. Boom. Now if there are less than 3 elements, then no hill or valley is possible. So we could just handle that with a guard statement by coming right here and saying guard new R dot count is greater than 2, else we could just return 0. Boom. Then we come right here and we declare a variable called result that's going to store our output for us. Now we're going to iterate through the array, excluding the first and last element. So we're going to say for I in 1 dot dot up to new r dot count minus 1. Boom, we're going to open up the bracket and we're going to check for hill if the current element is greater than both its neighbors, or by checking if the current element is greater than both its neighbors. We're going to do that by saying if new r square bracket I minus 1 is less than new r square bracket I, and two and signs, new r square bracket I is greater than new r square bracket I plus 1, then what we're going to do is we're going to open up the brackets. We're going to say result plus equals 1. Boom. Now we're going to check for valley by checking if the current element is less than both neighbors. So we could come right here and we could say if new r square bracket I minus 1 is greater than new r square bracket I, and two and signs, new r square bracket I is less than new r square bracket I plus 1, then what we're going to do is we're going to open up the brackets and we're going to say result plus equals 1. Just like that. Now all we need to do is return the total number of hills and valleys by coming right here and saying return result. Boom, y'all, that's all she wrote. Let's go ahead and give it a run before we submit it. Make sure it runs like it's supposed to. It's accepted. That's what I'm talking about. So let's go ahead and submit it. See what happens after we submit this thing. Look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, and I hope y'all do too. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.